Do you want to train a chat model like ChatGPT or Gemini? You'll need instruction completion data, but this data is expensive. Sometimes it costs tens of thousands or even hundreds of thousands. These people from Meta wrote a paper which proposes an iterative method to generate good quality instruction completion data using LLMs to reduce costs. Does it work? I'm honestly skeptical and don't think it will produce good results. But this research is from Meta, so I'm probably wrong. Let's try to prove me wrong. This paper is called Self-Alignment with Instruction Back Translation. Let's understand what is back translation first. Imagine that you want to create a machine translation model that translates from English to Chinese, but you have limited parallel data for English and Chinese. Guess what? You can create more parallel data. Take a pile of Chinese data and use any machine translation model from Chinese to English. Translate these Chinese data back into English. The term back is used because we translate text from the target language back to the source language of the system we want to create. Similarly, if we have even a small amount of instruction completion data, we can train a large language model to generate the prompt of that completion or answer. With that model, we can try to predict the prompt of any random text from any source. And the internet is full of text. We can just pick any paragraph from anywhere and ask our back translation model to predict the prompt for that paragraph. But this method will introduce too many noisy examples, as not all paragraphs might work as a good answer, and not all generated questions might be reasonable prompts. To fix this, the authors use a normally trained model to filter out bad candidates. This normally trained model is prompted and asked to rate the candidate examples from 1 to 5. In this table, we can see that if we only select data that got 5 points, we will get data that its characteristics are similar to the correct baseline data. And why it is iterative? Because the new data will be used to train another normal model, and then this new normal model will be used to filter the synthetic data again. So does it work? Let's look at the evaluation results. The authors call their model Humpback. I'm not sure if I'm pronouncing it right, but yeah, anyways, who cares? And wow, the results are really good for a model that was trained using way less original authentic data compared to the others. Remember that we compare the model to the other models which are the same size. We don't compare 7 billion models to 70 billion, for example. So what should I do in my project? Well, I don't know. You should try, but at least now if you don't have enough data, you can try this way to generate more synthetic data. But remember, not all synthetic data can yield good results. People from Climate GPT concluded that synthetic scientific data for climate is no match to real authentic data. Check more about their experiment in this video, and happy researching.